noted that it can be useful to reduce people, and it also reduces the traffic, so you have less machines in there, so therefore you have less ventilation required to push the diesel fumes out. And it's set up for long-term usage. You can use them in many different areas. You can operate many different headings with a continuous conveyor. So you can have different headings all leading to one area, and you can have dumping stations where you reduce the actual need for many haulage machines. In an example, I went over this. We also have, you can use some different examples include a vertical conveyor that you can use to export materials. So this only works for relatively low overburden mines. It does not work for a few thousand feet, but for a little distance, it can be used. You can use a vertical conveyor to lift the material up. But it is definitely a main haulage. You don't want to build the infrastructure if you're not going to use this area for a long time. So it is, and the machine, the TBM as well, can be installed as a continuous conveyor as it excavates. So it is being put in as the machine goes in. This will move us on to, we have an example of inside access, which is not a mine, but it uses multiple headings, and the conveyor for it has been used over 5 years. It had material from TBMs, road headers, drill and blast areas, all pushed to one conveyor to pull it out. We actually have a video on that in which one of our associates will explain how the continuous conveyors were used. On this project, they utilize almost all of the belt conveyor types that Robbins offers. There's the extensible conveyor, which attaches to the tunnel boring machine. Both of those twin conveyors discharge onto a six-link conveyor, which then discharges onto a vertical conveyor, which discharges onto an overland conveyor, which takes the material to the muck pile, which is piled up using a radial stacker. Maybe a short detail of how a conveyor can actually be used. That moves us into our conclusion. TBMs do have advantages in mining with foresight and planning. As we said, they take a long time to be manufactured, so planning is a key part in that. And if with planning, it can be used to great advantages, including economical advantages from long drives, as they have very quick production, and they use about 33% of the cost for operating costs. But for TBMs to work, the company must be willing to commit to the idea of TBMs, such as like Stillwater has. They have planned ahead. They know what they want to do, and you have to know where the drive at least is going to determine to be going. They use theirs. They use the geology to steer the TBM, but it is general, very small grade changes, and they found that out through extensive exploratory holes. So they knew the TBM could be used, and this must be thought about when you are using TBMs. I believe this moves us into our question session. I'll turn it back over to Desiree.
Thanks, Zach. We have a few questions for the Q&A. The first one I have, how cost-effective are TBMs compared with drill and blast operations in mines?
Well, TBMs for longer tunnels, they can be very cost-effective. You have to plan ahead for that to work. They use only 33% of the operating costs, but they have a much higher capital cost. With planning, they can be very cost effective, but it must be for longer tunnels. You really can't justify for really, really short tunnels overall.
Okay, and here's another question. Are some mines better suited for TBM tunneling than others?
Definitely. If you have a mine that is going to use short, quick drifts for excavating material or very small veins, and you don't want to access the vein, you just want to narrow vein it, you don't want to use a TBM. It just doesn't make sense because you're going to pull out too much waste rock and not going to offset the actual intake from the ore.
Okay, and this next one might be for Steve. How much downtime is required for one cycle of probe drilling?
Well, actually, that's a difficult one. I don't think I can give a straight answer, unfortunately. It's really dependent on what the nature of the probe drilling is, whether it's probe drilling or core drilling, and how many cores or probes need to be made, how far you want to go ahead of the machine. And as always, it's extremely dependent on what the geology is. I guess the main point is that when you want to do that, you can't do it while you're boring. You have to stop. You have to stop the machine and wait until that operation is done. I'm sorry, I can't give a concrete number there.
And here's one. What ventilation controls are typically used during production for the TBM to ensure fresh air at the working phase?
Steve, do you want to answer that, or do you want me to answer that?
Well, I'm not sure I really understand the question. Let me comment on it. Let me have something to add, Zach. The ventilation system is integrated into the tunnel boring machine. There's a fresh air supply that blows air up to the heading, to the face, and then suction draws air out of the working area where the cutters are, back through the scrubber, and it's discharged into the tunnel. That's normally the air is blown in a pipe, and then the tunnel itself is the discharge. I'm not sure that really answered the question.
Yeah, that's pretty much what I was going to say. The air is piped all the way to the front of the TBM, as Steve said, and it is then pushed straight into the face as much as possible, which pulls back some of the dust, but it is also, the dust is only watered down. But as it's being pumped in, because it's pulled straight from outside, therefore it should be pretty fresh air in all the working areas, and it goes, as Steve said, goes to the scrubbers and all that. So I don't think I have too much more to add. If that doesn't answer your question, maybe ask me in and give us a little bit more detail.
Okay, and here's another one. What are the benefits of TBM tunneling in mines over other methods?
Faster production is definitely a huge benefit, as well as you eliminate explosives from that section of the mine. You don't have to stop production and excavate everybody out of a certain section, so the explosion will be done. And by eliminating explosion, you also eliminate the residual effects on the surrounding rock, because using explosion, you're going to have more rock support required, and with the TBM, you have less rock support due to the fact it's a circular profile, as well as it doesn't have any blasting.
Are there any drawbacks to TBM tunneling in mines?
No sharp turns cannot be done. It's long procurement time as well. It's not planned for. It could take a long time to get it to the mine.
One of the other drawbacks is that you have to separate the ore from the spoil, and sometimes the ratio of ore to waste rock can be somewhat high. And that's a little bit different than when you're just mining the ore body itself.